Okay, so we're going to replicate the Vanderburg and Johnson 2014 SFF paper with lightkurve. So here's the paper we already saw in a previous notebook and screencast about how to understand the algorithm, how to replicate it with Python for the same exact source that was used in the paper. In this particular notebook, we're just going to show some of the features of lightkurve that include some of those algorithms just automatically. So let's go ahead and get started. We'll just include matplotlib and numpy, so really standard imports, and then these two parts of lightkurve. And then we will access a target pixel file based on its web address that supports either a local or a remote file name. Then we'll load this mask. We already loaded and saved this mask in a previous notebook here, so you can access that mask right there. So now we can go ahead and load that in and then see what that looks like. So we have a pink mask, which is our Vanderburg and Johnson, very similar to the mask that they used. It's probably a little bit bigger. And then in blue is the pipeline mask. So what's the default in the Kepler or K2 pipeline. So the next step is data exclusion. So in general, just excluding quote unquote bad data points. So in this case, course pointing before 2.5 days and anything with a non-zero quality flag. So you can see that's what they did in the paper. We don't exclude the thruster firing campaigns. In general, those are flagged with in K2 metadata in the quality flags. They happen not to have been in the engineering campaign. So we don't replicate that, but you could using the DSTT method. So we apply that mask, which looks very similar to NumPy. So you just hand index in with a Boolean mask, this keep indices, and then you have your trimmed lightkurve, and then you can normalize just to the mean, let's say, and that's your new lightkurve. And then we hand in the lightkurve centroids and all that information into this SFF corrector. Very good. Row. That's good. Run that, and then we can see that goes quite quickly, and you get back this SFF, which has all sorts of different things you can tap into. But let's say we want the trend, the long-term trend for astrophysical purposes. That's useful. Maybe less so for planet searches, but we can add that or multiply that back in so that we can see what the long-term trend is. That's very similar to what the paper does. And sure enough, you can see the raw data with the systematics from Kepler motion. And then here you see the SFF corrected version, including some of those thruster firing time samples, which we'd like to get rid of, but we didn't include in our flags. So, but very similar performance to what we see in the paper. So almost identical, slightly steeper slope just because of the mask again, or slight nuances in say background subtraction or something, but very similar to figure 5. There's a few other convenience functions included, so you can do this. Let's plot the normalized flux versus arc length. So that's a nice thing to see. And that's pretty good. You can also look at, say, the rotated centroids or something and see what that looks like. So pretty good.